Hello YouTube, welcome back to my channel. So in today's tutorial we're going to go over exploratory data analysis. So I'm going to give you a quick introduction to exploratory data analysis, and in this series as we go along we'll cover more videos. We'll do more projects on cleaning data and doing data analysis. So currently I'm having a new series on my channel on data cleaning. So along with data cleaning, after data cleaning, the next step is to learn how to do the exploratory data analysis, after which you can learn how to build models. So in this tutorial I'm going to go over all the basics of exploratory data analysis. So let's jump right into it. So what is exploratory data analysis, as you might ask? So exploratory data analysis is also commonly called the EDA in data science. It's also called EDA in data science, right? So I got this definition from this source right here, and this notebook is going to be made available on in my GitHub repository. The link to this to the repository is in the description below. So from this source I got that in statistics, exploratory data analysis is an approach for analyzing data sets to summarize their main characteristics, often with visual methods. Okay, so if we are trying to summarize the different characteristics and attributes of data, mainly using visual methods such as graphs and other stuff like that, that is what exploratory data analysis is. So before you do after you clean your data, getting a data, cleaning the data, then you need to do exploratory data analysis, and exploratory data analysis to help you to define to understand useful and very useful information from the data that can help you in building a model and also doing model selection. So EDA does not only give us insight into our data, it also also involves pre-processing of data for further analysis and model development by removing anomalies and outliers. Okay, so when we are doing expert data analysis, it helps you to detect outliers and to remove outliers, and this makes your model to be much better. Okay, so expert data analysis, this makes data cleaner for machine learning purposes. Expert data analysis is a source of information for making better business decisions, as well as choosing or selecting which kind of models to use for your data. So as we'll see as we go along, I will explain to you how all this comes into play. So why do you need to perform exploratory data analysis? So now the first one can be exploratory data analysis to help you to remove anomalies, outliers, and unnecessary values from your data set. It helps you to prepare data for analysis. Cleaner data equals to a better model, as they always say in machine learning. Your models are only as good as your data. It helps in developing a better ML models, because if your data is good, then at the end you probably have a better model, right? It helps in choosing the best machine learning model. So based on the graphs that you draw and other stuff, it can help you to spot patterns, and these patterns can help you to decide which machine learning model to use. So before exploratory data analysis, there are two main steps that we need to follow. The first one being you need to do data sourcing, and then you also need to do data cleaning. So let's go over what data sourcing is. So the process of obtaining data for your machine learning model or any data analysis project is called data sourcing. And in data sourcing, there are two main sources that we can get data from. There are public data sources, and there are also private data sources. So public data sources, these are data sources that are made available to the public, and anyone can use them without any restriction. For example, Kaggle, UCI, GitHub Awesome Data, data.government.uk, and other sources of data like that. So all these public sources of data you can use without any restriction, and the link to all these websites are here, and so you can find the link again in the description below. We also have private data sources, right? So private data sources, these are data sources that are owned by organizations or are used for in-company purposes and are not made available to the public. So to use these data sources, you need to either be working for the organization or be a part of the organization, and you're trying to build something for the organization, right? They don't allow anyone outside of the organization to have access to this data, and these are called private data sources. So now that we have covered sources of data, let's look at the data cleaning. So data cleaning is the second step of second step that we need to follow. So it's actually the second step we need to do before the EDA. So I have the whole series covering data cleaning. So if you are new to my channel, kindly consider subscribing and check on my channel main page. You'll see the link to the data cleaning series where we learn about data cleaning. So in this video, I'm not going to go into depth about data cleaning, since I have a whole series explaining what data cleaning is all about. So in data cleaning, we'll be dealing with different things such as re-indexing of rows, dealing with anomalies or outliers, incorrect data formats, missing values and stuff like that, incorrect column names and other stuff like that, renaming columns to their proper column names and other stuff like that. So we're doing it missing values. You can deal with the MCAR, which is missing completely at random. These are values that do not depend on any other feature in the data set. And then you also have MAR, which is missing at random. These are values that values may be dependent on some other features in the data set. We also have MNAR, okay, which is missing at random. These are missing values. These missing values, these missing values right here. So these missing values have some reason for why they are not recorded, right, or why they are missing from the data set. So there are reasons why they are missing from the data set. So once that you have gone over the quick introduction whereby you get data sourcing and data cleaning, let's go over let's go over an example of getting the data and then doing the data cleaning. So I'm going to be using the housing price data set from Kaggle, and it's part of the Kaggle competition on linear regression, advanced linear regression. So you can get this link to this repository or this data file here, right here. So you can just click on this link and then get access to it. If you want the link to the notebook, the link is going to be in the description below. So once we have the data set, this is a public data source, right? So we're using a public data source and we obtain the data. So I went ahead and simply read the data into a Pandas data frame, and this is how the data looks like. So I can scroll ahead and I can see we have 81 columns, right? So if I do the shape, I have 1,460 rows and 81 different columns. So you can see if I just do df.info, it gives me all the names of the columns along with their different data types. Okay, so you can see the names of the column along with the different data types that have been used. So once we have that done, let's go ahead and deal with missing values. Let's check if we have any missing values, and you can see we have missing values right here. So let's go ahead and calculate the percentage of missing values for each individual column. And the percentage for calculating missing value, the formula is going to be missing values over the total value times 100%, right? So I did that, I passed that in, I got all the missing values and I sort them based on descending order. And then I simply went ahead and got the percentages using this formula right here. And then I went ahead and joined all the data into a data frame using these different column names, and I simply print ahead the first 25 rows. So you can see that the first 25 rows gives me this data. So you can see the percentages that are missing. So you can see the public QC, which is the pool QC, which is a pool quality. You can see that we have 99% of the data missing, right? So we just have almost all the data being missing. And then we also have a MISC feature, which is we have 96% missing and other percentages like that. So we can see that some data have too much percentage being missing, so we can go ahead and drop them. So I went ahead and dropped the ones that have a missing value which is more than 10. So if the missing value percentage is total missing value is more than 10, we're simply going to go ahead and drop it. So I dropped it, that one, and then we can see now our columns have reduced to just 65. And again, I tried to check the missing values, and I tried to get the max of the missing value. We got only 8, right? Because if you look, we dropped everything above 10, so we have this and this remaining. So I went ahead and I fill in those values with the values that are before. Okay, using NumPy fill NA, and the method is I fill before, means that I'm using the value from above to fill it. So now we check for missing values again. You can see I have no missing values, and we still have 65 columns and 1,460 rows of data. So I went ahead and did a simple statistical summary, and I can see the different statistical summaries of the different numeric features. So it will give you the statistical summary of the different numeric features of our data set. So based on that, you can go ahead and do a basic statistical terms. So we have this STD, which stands for standard deviation. This basically tells us how much of our data deviates from the mean. We have the mean, which is just the average. We have the percentiles, and then finally we have the max price. So I'm going to be focusing on the sales columns. Okay, so to 25%, the percentile of 25%. Okay, so if you scroll this way, 25% of the houses sell at this value, which is I think 9,900 and I think it's $129,975 dollars, I think. So I think these currencies are in dollars. Okay, so 25% of the house sell below or below that or exactly that value, and 50% of the 50% of all the houses sell at this value or below that specific value, and 75% sell at this value or below that value, which is about $214,000 or below, which is 75% of the houses. And you also have the max price, and you can read all that data from this column right here. And I only focus on the sales column, sales price column. You can focus on any other column that you feel comfortable working with. And if you want to read more about percentiles, the quantiles, and other stuff like that, I have this link here that points to a good article where you can explain to you all about quantiles, percentiles, and other stuff like that. So let's move on to handling outliers. Okay, so our data might have outliers. So in statistics, an outlier is a data point that differs significantly from all the other observations. So whenever we have an observation that differs significantly or is just so far away from the rest of the observations, then we can call that an outlier. And we have two main types of outlier. There is a univariate outlier, and there is also multivariate outlier. So univariate outliers, these are outliers that are based on only a single variable. Okay, let's say that I'm collecting data about ages of people, right? And I see one person is 1,000 years old. That is very far from the rest of the population, right? Which will be around like 80, 70 years old. So 1,000 years old is just too far. So that person is probably an outlier, right? Because it's just too far from the rest of the observation. So that is just a univariate outlier, because we are focusing on only one variable, in this case, which is age, right? There's also something called the second type of outlier is a multivariate outlier. So in the multivariate outlier, we don't focus on one variable, we focus on two or more variables. So let's say that I'm collecting again, I'm trying to collect data about widows and their different ages. Okay, so let's say that a person who is 12 years old, in the univariate analysis, or in the terms of univariate data, that 12 years old is not an outlier, right? Because there are a lot of people who are 12 years old. But if you come to multivariate outliers, let's say that a person is 12 years old and is also a widow at the same time. That is weird, right? Because most widows are maybe they can be above maybe like 30 or something, but the person who is 12 years old and the same time as a widow is an outlier. But just looking at the age of the person as 12 years old is not an outlier, like just a univariate analysis, univariate outlier. But if you combine it with the widow status, then a widow who is 12 years old is just too far from the rest, right? It's just an outlier that doesn't really exist. Yeah, so that's a multivariate outlier. And to read more about outlier, you can click on this link. This explains it properly. Okay, it's a core article, so you can read more about that article. So you can also go about into data standardization, which is just a good way to perform to make sure that all your data is according to a certain scale, so that you can avoid any problems, because machine learning models perform best whenever your data is standardized and normalized. Okay, so let's go over to data analysis. So in data analysis, the process of data analysis is defined as a process of cleaning, transforming, modeling data to discover useful information for business decision making and building different machine learning models. So there are three main types of data analysis. So there's a univariate analysis, there is a bivariate analysis, and then there is a multivariate analysis. So let's go over what is a univariate analysis. Univariate analysis is a type of analysis which involves only a single variable. So if I'm doing analysis of data over a single variable, that is called a univariate analysis, which is also called a one variable data analysis. Okay, so there are many types of univariate analysis. So let's go over them. Let's talk about categorical and ordered univariate analysis. So in this is a type of univariate analysis in which the ordering of the categorical variables has no influence on the data. For example, if you're trying to analyze data of that contains a column of gender, right, the ordering of either male or female has no impact on the data, because the first one is that the gender column having male or female is categorical, and then it's also unordered, because the ordering doesn't matter whether male comes first or female comes first, it doesn't matter. So if we're trying to analyze such columns, it's called the univariate analysis. There's also another type of categorical ordered univariate analysis, and this is based on analyzing categorical data, but that is in an ordered form. So let's say that we're working in the data set that has a feature of months, right? So months are have order ordering, like there is January, February, March, April, May, and other stuff like that, right? So they have an ordering to them. So if you're dealing with such categorical ordered variables, they're called categorical ordered univariate analysis. So whenever you're working with the categorical data, there are many forms that you can visualize it. You can use a bar chart, you can use histograms, pie charts, frequency distribution tables, and frequency polygons. Okay, there are many other data types that you can use as well. Data visualization you can use as well, charts. Yeah, so let's go ahead and try to do plot some simple bar charts. In this case, bar chart, you're trying to see the sales condition, which was the more sales condition. So I went ahead and created a Matplotlib figure, and I simply said that I got the data, and then I got the sales condition, I got the value counts, and then I simply did a plot on it. So I plot a horizontal bar plot, and you can give it a title of bar chart of the sales condition, and I simply went ahead and displayed that chart. You can see that the sales condition that is mostly prevailing is a normal sales condition. So this is an example of univariate analysis, since you're only focusing on one variable, which is a sales condition. And it's also categorical, because there is these are categorical values, and it's also unordered, right, because the ordering of this doesn't matter. So it's a categorical unordered univariate analysis. So let's move on to histograms and try to plot a graph of histograms showing the sales prices. Okay, so we have all the different houses having the different sales prices. So I went ahead, created a figure, and then I did a histogram of the sales price column, which is this one right here, df.sales price column, and then I said KD equals to true, because I want this Kennard density estimator line drawn. Okay, and then I specified the title, which is the house histogram chart of the sales prices, and I went ahead and plotted that graph. You can see this how the graph looks like. So most houses, they are sold around $1,000, okay, $100,000, I mean. So most houses around $100,000, and there's some of them which are $700,000, which are just so far from the rest. So you can think of this like an outlier, right, because these are very, very far from the rest of the data. So I went ahead and calculated the skewness and the kurtosis. So the skewness was about 1.88. The high degree of skewness means that there are a high degree of outliers. So we can see these are outliers right here. So this is a high degree of skewness. So you can see that this data is positively skewed, right? Since the tail of this plot is pushed most to the right side, so it's positively skewed, and you can see because this is because of outliers like the one here. So we also did the kurtosis, and the kurtosis was 6.53. So we can see that the standardization means to transform data to a mean, or to have a mean of 0 and a standard deviation of 1. That is what standardization is. I just added that for an added bonus. So let's look at the pie chart, and let's try to plot some graphs using pie chart. So okay, this is also part of univariate analysis. Okay, so I created a figure, and I went to plot some pie chart based on the year the house was sold. So you can see that the most houses were sold around this one is the highest, so most houses were sold around 2008. So that you can get that data from there. So this is a univariate analysis. You're only looking at the year in which the house was sold and not any other value. Okay, so let's look at the statistical measures of using univariate analysis. So we have the sales price, right? We can just do sales df.salesprice.describe, and it's going to give us the mean, the max, the standard, the percentiles, and the standard deviation, all that information. So you can see that information all here. So this is how you can do a univariate analysis on a single column in Pandas using the describe function. So you select the column, and then you do the describe method on it, and then you give you the univariate analysis of that specific column. So let's move on to bivariate analysis. And bivariate analysis, as I said, include at least 2 or more variables. Okay, so there are many forms of bivariate analysis. The first one is a numeric analysis, in which both variables involved are both numeric variables. So okay, so I made a mistake here. So bivariate analysis involves strictly 2 variables, just 2 variables and not more. Bi means 2, so bivariate analysis involves just 2 variables. Okay, so we have different types. The first one being numeric analysis, in which both variables are of type numeric data. Okay, and also have numeric categorical, and each one of them is numeric, and then another one is categorical. And also we have categorical, in which both of the data is categorical. So both of the variables in the analysis are categorical. So there are many ways to visualize do a bivariate analysis. So let's go over numeric analysis, and for this is in which both variables are numbers, right, and numeric type. So we can plot this using scatter plots, correlation matrices, box plots, and then pair plots. So let's go ahead and load the data, and then I tried to get the scatter plot. So I did scatter plot of the lot area, and the lot area, if you look at the data that was given, if you go up here and click on this link and read more about the data set from Kaggle and the data set documentation, we can using this link right here, you'll be able to see the different definitions of the column, like what each column stands for. So I have this one right here, which is lot area, which is a lot size in square feet. So I went ahead and tried to plot this in using a scatter plot. So I got the information. I'm plotting basing on this the plot area and then the sales price, right? So the plot area and the sales price, I'm plotting a scatter plot on basing on these two features, because we're using a bivariate analysis. So y will be the plot area, and then x will be the sales price. So this is a sales price, and this is the lot area on the lot area on the y-axis. And my data is coming from the data frame that we loaded, and I give it a title of sales price versus lot area. And you can see the graph. This is the graph right here, and using this graph you can see you can spot some outliers, like this one here is just very far from the rest, this one are just very far from the rest. Even this you can consider them as outliers, so you can get rid of all of this and some of this right here, just to clean your data and make your data better. So this is one of the advantages of exploratory data analysis that we were saying earlier on, which is it makes easier for you to spot outliers and abnormalities in your data. So let's move on to pair plots. So pair plots, this has pair plots, and you can plot pair plots based on different values. So in this case, I plot based on 3 values, which is actually not a bivariate analysis, right? So if you just if it's it will be a bivariate analysis, you have to get rid of one of these columns, okay? So we can the sales price, the price at which the house was sold, the quality, overall qual, and this is the rate, the rates, the overall material and finish of the house, and then overall condition rates, the overall condition of the house at the point of selling the house. So you can plot this, and you can see we have these different plots right here. So you can see the sales and then the sales price here, and then you can also see the overall condition, overall quality, and then the sales price right here. So as the quality increases, the sales price, the prices start at a higher price range, right? Because the more quality the house, the more expensive it would be, right? So overall, we also have overall condition, and you can see that the better the condition, the more expensive that house is. Great. So once we have that, you can also go to correlation and to draw correlation matrix. And if you don't know about correlation matrix, I have a whole tutorial on my YouTube page explaining correlation matrix and how to read a correlation matrix and all that. Okay. So I'm trying to plot a correlation matrix between the quality of the house, the overall quality, and the condition of the house. Again, this is not a bivariate analysis because it includes more than one variable. So if it's a bivariate analysis, I send you to get this notebook and remove one of these columns and then do a bivariate analysis. So you can plot, I got the correlation matrix, and this is a correlation matrix, and I use a heat map to plot it. So this graph is called a heat map, and you can see that there is a overall quality, and the sales price has a correlation of 0.75%, right, of 0.79%, which is about 80%, right? So it's 0.8% correlation. Okay, yeah, that's basically it. And you can see the correlation between overall price and overall price is 100% because it's the same thing. And then sales and sales price have a correlation of 100% because it's just the same data, right? But overall quality and the sales price has a correlation of 0.79%. So that's a heat map. So let's go over to look at box plots. Also, box plots are also called whisker plots, and you can use this for bivariate analysis. So in this case, you're going to perform a bivariate analysis between the sales price and the overall quality. And you can see, based on these box plots, you can see that the overall quality, as the quality of the house increases, it starts as a higher price, right? So you can even see, so this is a minimum. So this line here represents the minimum, this one represents here the first quartile, this one represents the second quartile, which is also called the mean, and then this line represents the third quartile, and this one represents the maximum sales price. Okay, so this one here is the median, which is also called the median, which is also the second quartile, and the space between here and here is the interquartile range, which is the difference between the first quartile and the third quartile. So you can see, as the overall quality of the house increases, the house starts at a higher prices and it's much more expensive. So as we go, we can see that the house becomes more and more expensive as we go, as the quality increases. So that's a box plot. Okay, and these lines are also called the whiskers, so it's called a whisker plot. Okay, so let's also go to numeric and categorical analysis. Numeric and categorical analysis. So this is a form of bivariate analysis in which one of the variables is a numeric one and the other one is a categorical value. Okay, you can plot this using box plots and scatter and the box plots and bar charts. Okay, so I have drawn another box plots right here, and in this a correlation matrix heat map between the cells and then the roof style. Right, the roof style is the type of the roof that was used, so you can see the correlation in here. This is the sales price and then the roof type that was used. So you can see that the most expensive one is the hip roof type, and you can see even the median ones is above most of the median values here, except for this one here. This one looks like a very most expensive one, because even the minimum value starts from around 1,800 and something, and you can see 1,000. This is about almost to $200,000. So this is the most expensive one. So the shade one, the house that have a shade roof type are much more expensive, and you can see this in the plot. And these these lines, these dots right here are outliers. So you can even use box plots to spot outliers. So these are considered outliers, and this is one of the advantages of performing explorator data analysis. It helps you to discover outliers in your data, right? So the cheapest house you can get with the roof type of cable, which starts for a very minimum price, even less than $50,000. Okay, so that's just the type of categorical and numeric data analysis, which is a bivariate analysis, right? So let's go to the last step of bivariate analysis, which is a categorical analysis, in which both of the variables performed or used within the bivariate analysis are both categorical values. Okay, so in this time we have the roof style and then the sale price. Okay, but this is not a categorical because the sales price is a numerical. So my challenge to you is get this notebook, try to go through the data, find a way where you can make this one to be categorical analysis, and let me know in the description what you found. Okay, let's move on to the last step of analysis, which is called the multivariate analysis. So multivariate includes so univariate includes just one variable, bivariate exactly two, multivariate 3 or more. Okay, so when you have 3 or more values being involved in analysis, such as in this case we have 3 different columns, then this is known as a multivariate analysis, and you can see the multivariate analysis right here. So you can go ahead, this is a box plot, a heat map of the sales price, the overall quality and the overall condition of the house, and you can see that relationship right there. Okay, so the overall quality and relates to the overall condition with a negative correlation, while the sales price and the overall quality has a positive correlation of about 0.79%, while the other ones are 1 because it's the same value. Okay, you can also draw this for all the other for the whole data set. I draw this for the whole data set, and using on this you can spot you can use this heat map to spot multicollinearity in your data. So multicollinearity is when one variable I'm not going to explain multicollinearity in this tutorial, but multicollinearity when two variables are highly related, okay, to each other, such that it prevents your model from identifying purely how the pure influence on one variable on the prediction. Okay, so that's basically this introduction to multivariate analysis. This video is not for multivariate analysis. If you want me to make a video on multivariate analysis, leave a comment in the comment section below. I'll do my best to get back to you. So you can see I just plotted the correlation matrix, the box plots, the heat map of the 10 most correlated values to the sales price. So these are the 10 most correlated values to the sale price. So you can see this one here is the garage area. It has a 0.88% correlation with the sales price, because the bigger the garage, then the more expensive the house, right? And you also have the year built. The year built has this one here, total rooms above average and above ground, has a high correlation to the sales price of about so it has a high correlation with the living area, about I was 0.8%. And this one, as I was saying, I made a mistake actually here. You see the garage area has a correlation to the garage cars, because the bigger the garage area, the more cars you can park, right? So it has a correlation of about 0.88%. Yeah, and you can see you can spot other values right here. So you can see we get this value right here, which is a living area, has a 71%, 0.71% correlation with the sales price, because the bigger the living area, the more you're going to pay, right? Even this one here, which is the first floor, I don't know what's this feature for. You can read more about the different features using the dataset documentation. And you can see that this has a 61% correlation with the sales price. Yeah, and that's how you can perform different perform bivariate analysis on data using multiple different columns. Again, we plot again the pair plots as we did above. So it is also there's the pair plot that we used above, and also plotted the pair plot against all these values, and you can go ahead and try to analyze all of this. So this is all about multivariate analysis. Okay, so I also have some video here about dealing with multicollinearity, and it's important that you know about multicollinearity since it helps you to analyze your data even in a better way. So when you're performing a linear model, right, you're trying to build a linear regression model, you need to find multicollinearity between the data, because multicollinearity makes your linear model perform poor in case if you don't take care of it, right? So this so multicollinearity, let's say that we have these variables, right? So let's say that M1 and M2 are highly correlated. We call that multicollinearity. This will prevent us from a model from understanding the pure effect of M1 on the final prediction, since M1 and M2 are highly related. So if M2 changes to a higher value, even M1 will change to a higher value. So it prevents the model from understanding the pure effect of M1 on its final prediction. So that's what is called a multicollinearity. And multicollinearity can be there for many reasons. There's also something called dummy variable trap in machine learning, whereby if you are trying to perform dummy variables, you might run into this area of multicollinearity. Okay, that's why we usually drop one of the columns if you're using one-hot encoding to prevent any multicollinearity in our data. Again, if you want to check about my data cleaning, check out my YouTube page, and you can see that series on data cleaning. And let's go to detect if you are which features of yours have a high multicollinearity. You can use the variation, the VIF, which is value inflation factor, and this comes with the stats module in Python. So you can just from stat module.stats.outlier influence, you're going to import the variance inflation factor. Okay, so this is actually variance inflation factor and not value. Okay, my bad. So forget this is variance inflation factor. So you can even change it right. Let me just change it right. So is variance inflation factor right here. So using the VIF, we can calculate the variance inflation factor of this specific column. So I've selected these columns right here, and I try to find the multicollinearity between these columns. So basing on the heat map, the heat map we have right here, I'm trying to find, using the features I identify from here, spotting just by analyzing this data, I spotted some values that I think have a high correlation with the sales price. So I'm trying to identify if there is any multi-collinearity between those features. So I selected some of those features, and I simply calculated the valuation, the variance inflation factor. And you can see that we have the variance inflation factor right here, and you can see the overall quality has a high variation inflation factor of about 0.479. That's so high. So if it is 1, there's no multicollinearity. If it's above 5 to 10, that's from 5 and above, that is, we can consider that as a high multicollinearity. So you can see all of these are very high multicollinearity. So one of the things you can do is to drop the related features, and there are many ways to deal with this multicollinearity. So you can see that I brought this bar graph of the variance inflation factors. You can see that overall quality has a high multicollinearity. So I went there. So as I was explaining how to interpret multicollinearity is if it starts at 1, means that it starts at 1 and there's no upper limit, and if it starts at 1, that means there's no correlation with other variables. But if it's from 5 above, 5 or 10 indicates a very big multicollinearity between that variable and other variables in a data set. So the way to fix multicollinearity is actually dropping the corresponding values with that have a high correlation with the value that you're working with. And in case if you talk about one-hot encoding, that's why you have to drop one of the columns to prevent high multicollinearity in your data when trying to clean the data. yeah, so that's all for this tutorial. And again, if you enjoyed this tutorial so far, give this video a thumbs up, subscribe to the YouTube channel, and if you want me to make more videos, I'll make more videos. We'll do different projects about data, exploitative data analysis in Python. This is just a quick overview to go over the basic terminology. So in the future videos and the upcoming videos, we'll go over going over projects and actually coding. So we'll get data set, we'll try to analyze the right different questions that we wish to answer, and go and analyze the whole data set to perform the exploitative data analysis. So if you enjoyed this so far and you're new to my channel, please kindly consider subscribing for more videos on data science, machine learning, Python programming, web development, and other blockchain development, and other stuff in general. So if you're new to the channel, please kindly consider subscribing. Since most of you guys watch my channel, you're not actually subscribed, so subscribe to the YouTube channel. That will help me and keep me motivated to keep making this video. So go ahead and hit the subscribe button and hit the notification bell, and also hit the like button, and share this video with anyone who you think might find this helpful. So thanks for watching. I'll see you in the next one. Keep safe.